Hello. Today I will be working on my biggest project yet, my self-sustainable water-to-hydrogen converter, in hopes this can help society in the future. In this project, I will be showing you how to use it with solar, and this is going to be my big project that I hope to really bring back into the world because there's been machines similar to this, but none like how I plan to do it. Well, let's get started, and I'll show you with the basic science and wiring. To start, I wire it in a parallel circuit, allowing current over voltage. Now, if I stick everything to my multimeter correctly, not just kind of thing, I should be getting, that's not right, 20 volts. It would be more, but the sun's a little low right now, and it's kind of cloudy, but that's about right. Now, with a current circuit, or parallel circuit for extra current, we are going to be hooking it up to this grade 2 titanium to help prevent corrosion, or at least make it much slower, since grade 2 titanium is a much higher grade metal. I don't have the proper drilling equipment, so we're just going to be using electrical tape to make sure that these regular wires don't corrode. So I'll be right back. Now, after some sketchy wiring, you can see that we produce oxygen on one side, and those bubbles that are being produced right now are hydrogen bubbles. Now, I'm not going to keep this on forever because this can heavily corrode the metal that I'm using right now. But as you can see, it bubbles very quickly, and you can see that all that right there, all those little bubbles that are forming are tiny little hydrogen bubbles. Now, of course, this would be more powerful on a scale, except, well, the sun is setting, so solar is not at full potential. Now, hopefully I'll get this rewired tomorrow, but the idea is basically the solar will run on its own and produce the hydrogen, but at night, the battery will help produce hydrogen. Now, the battery will produce slower because I have it on a slower current, so the solar can charge the battery and produce hydrogen at the same time. This should hopefully theoretically create a usable fuel if power generation ends up being negative. However, if the power generation is a positive, I will be able to fully generate my own fuel and power generation for like a larger scale of a house. Now, I already have some pre-made hydrogen that I made with this setup, but I didn't record it since I made it a couple months ago. So I will go get that hydrogen and kind of show you how this works. This is what happens if I do use the wrong kind of metal in in making hydrogen. You can see that it rusted really quickly and the water's kind of yellow. However, all that air pocket right here is all hydrogen. The idea behind the hydrogen is we will be drilling a hole through the top of the tank, and we will be running a one-way flow tube which allows gas or liquid to flow in that direction. Now, the idea is we run it through here, and I will put the burner nozzle, of course, right here, and that will then light and allow the Stirling engine to run. Now, the difference between a typical engine and a Stirling engine isn't crazy different, but it runs off the same basic idea of compression. Now, when you burn the heat here, there is also a tube that runs off of a typical normal air temperature. Now, the colder this is, the heat difference is what kind of allows this to create almost like a pressure difference, and that'll allow this engine to turn. Now, I will go and get some alcohol and light this little wick to kind of show you what the Stirling engine looks like when it's running. Before I do that, here's a basic diagram of a Stirling engine. As you can see, the hot cylinder is, of course, the one that gets heated, and the displacer is where that little piston is. And that uneven pressure allows the Stirling engine to turn, and a tiny bit does exhaust through the work piston, not the displacer. However, for the most part, it is kind of an interesting engine. There's not too much else to say besides the idea of the flywheel and that when that turns, I will be running like some sort of belt to be turning a generator or motor that'll help charge a battery. So we'll see how this works, and if everything goes according to plan, this is what it is going to look like. For anything really else, besides replacing that candle with a hydrogen burner, that's about the only thing I'm going to be making a huge change to, but for the most part, the Stirling engine will not be changed. The only thing I might change will be replacing some parts with something like a carbon fiber material if I were to make a giant Stirling engine to help save weight and space a little bit. So I just filled this little glass area with a wick with isopropyl alcohol. Now, of course, this will be running hydrogen eventually, but yeah, this is just the basics of how a Stirling engine will work. So I light it, and it'll take a little bit to begin to heat. Now, in this time, I would usually talk about a sponsor, but unfortunately, I'm not sponsored yet. Hopefully, I can find somebody to help me out with that. Now, I'll turn this guy around so you can kind of see the flame better. It looks pretty cool, but you'll see a little, let me turn this better for y'all. When I turn it, you'll see that light word go. Now the heat difference allows our Stirling engine to run properly. This is super crucial. Now as the heat goes, it turns the engine. Of course, it's running about as fast as it can right now off of a low heat. If I were to add something like our hydrogen fuel, this is just typical butane. It allows it to run even faster. Now you may be thinking, well, now what? Because maybe I had negative power generation, what's my backup plan? Always have a backup plan. Well, it's actually pretty simple. Propane fuel. Now, the idea behind this is solar is pretty self-sustainable with batteries. So as long as it can maintain and still create our generation, even though we might be losing a tiny bit of power, or maybe we just don't even skip out on batteries and we just don't run it at night so we don't lose power and it just kind of evens out, we still have a usable propane fuel. Now, if I were to use this hydrogen, which I will attempt to burn later, we'll see, because I kind of have to drill through this, so it may mix with oxygen in the process. But the idea is basically the same thing. One-way flow tubes hopefully not allowing backfire and kaboom. But we'll, of course, have different heat temperature sensors and valves to close. But the basic concept is then we have burners along the house or just typical gas for heating water. You now have a clean fuel that when it burns, its outcome is water. Now you're probably thinking, how is that even possible? Well, when separating hydrogen and oxygen, you then come to the process of just pure gas. The oxygen will probably just flow out into our atmosphere, completely safe, no kind of harmful exhaust. Now the hydrogen, when it goes back out, it eventually mixes with that air and oxygen and becomes part of the atmosphere again, allowing not huge amounts of water, but some to be produced. If you were to use this on, for example, a big scale like a car, that car would have a slight amount of water coming out the exhaust. Drinkable, but probably wouldn't recommend it because there's still, possible chances of, metal or slight lubricant oil contamination. So maybe avoid drinking it. However, you'd probably be fine. Now, even though this seems like a wild concept, it's not used very often because a lot of these guys who've been trying to do what I do have unfortunately died. Of course, if my science isn't correct and those guys are, then I'll probably be fine, but that's why I'm going to probably avoid using it in cars and just probably work on small home scale areas. So small propane areas for houses, and I'll leave the Saudi Arabias alone because I love my head. Didn't really feel like losing it, and I also love being alive, and I kind of like still making money in the process. Now, this is my big master project. This, of course, it's still in the very early testing stages, but theoretically it's possible. Now comes the fun part. Can I burn hydrogen by just basic drilling it and avoiding mixing it with the atmosphere? That's what we're going to find out. I have to find something good enough to poke through metal that won't break in the process. Of course, I just kind of got my... Oh, there we go. Hopefully this will work. If I need to sharpen it, I will. That looks good enough. For the most part, this should be safe, but chances are never zero of you getting hurt. The risk I pose here, like this is absolutely worst case scenario. I start to burn the hydrogen, it creates a vacuum or decides to explode inside the glass, shooting glass shards inside of me, and I bleed out. Hopefully that won't happen.
You're confident.
Cool, I just burst it. See if there's something. I think it already mixed with the atmosphere, but I did see a little something kind of go out. Of course, I could be wrong. Let's see if I can see what it looks like on the inside here. Something's getting put out because it's not holding. Boy, just got it red hot there. Oh, it did burn a little bit. Wait, let's see if I can do it again. Ooh, it's burning. Such a small amount, though. You might not be able to see it. I can smell it burning in the metal and Sharpie, but I don't think there's enough gas yet. Oh wait, I do see a little something. It's kind of hard to see, but it is burning. I did cut the video off a little bit early due to my shaky hands because I was nervous. Now, it will flow more consistently through one-way flow valves and a bit of compression too. Now, this is only a theoretical scale and very, very small scale, but I did see some burning in there. This is still very hot. I'll just continue to cut around this. Come on. Cut. There we go. I'm pretty much breaking like a seal here. It's done by my crappy taping. Smells like something was burning because I can smell the steam in here. So that means that the hydrogen did burn for a small amount of time. Of course, it burns so hot and so quick when you don't compress it. It just kind of only burns for like a few seconds. But I had such a small flow valve, I was able to hold it slightly longer. Now, I hope this is good enough for y'all and I explained it well. This is all a huge project that will take possibly years of research and experiments and fails. And I know this isn't going to be easy at all. But with the help of a team maybe, or pretty much anybody that can help, I should be able to help change the world. Now, I am less confident in power generation, but I am more confident in propane fuel replacing. As more houses are powered by America, and more houses are built, and more fireplaces or cars are made, and more drivers come into the world, the air quality will go down. However, as long as we can try to make ways to prevent this, we should be okay. But if you go to areas like Boston or New York or any heavily population dense city that isn't very big, you'll see that a lot of the air there isn't very healthy. And part of that reason is due to typical gasoline cars creating their exhaust and smog. Now, on this scale, it just kind of gives you a bad smell and might not be great for the environment, but as we become a more advanced civilization and move to a more population dense area or start having a lot more cars on the road or buses or people, this can become a much more dangerous level. Now, of course, I'm talking maybe 100 years in the future, maybe longer, maybe shorter. I don't know, because frankly, I don't know what the future is going to look like. If everything goes according to plan, places like New York, Boston, or China even, should end up with a lot better energy efficiency and air quality. Now, there's one more thing I forgot to mention, is that once I build my hydrogen generator, it will be initially more expensive build, and you might think it's not that feasible, and you might want to do something else, like go back to gasoline. However, it is much better to use this, and here's why. It will be much cheaper in the long run. It may be initially expensive to build due to high-grade metal, or compression systems might cost more, and the idea of just building it costs a lot and takes up a lot more space than a typical gas or oil pump would. However, if we were to build them by Great Lakes or areas like that where there's high amounts of fresh water, we can totally make this a very usable system. Now, I know that this does pose a risk to there being higher chances of water shortages, which is why, as long as this freshwater hold generator goes right, our atmosphere should be able to actually possibly give us higher rain too, due to there being more condensation in the general vicinity of our cities. This is only theoretical. Now, if I were to move to something like saltwater, I could. However, it would take a lot more steps and more solar, and it would be a lot more complicated. But it's not impossible. The idea for that is you would use something like a DC heating coil and just boil the salt water into steam. It basically is a small extra step you would take, and it would fill the fresh water it would take a lot longer to get your proper amount of fresh water to generate our fuel. However, it would be a lot easier, and since seawater is much more abundant in many countries and even states of America or landlocked countries, it probably would be more feasible to do something like that for those coastal areas. Now, for those more central areas, like the border between Canada and the United States, those are more kind of landlocked areas, but we do have the Great Lakes there, so those could be used for our freshwater propane or gasoline replacement systems. The idea is to hope that people will catch on to this and start replacing their houses and cars and maybe even planes in the future. I'm really hoping this goes well, and I'm really hoping I can change the world. Now, this isn't my biggest goal though. If I do make my honest money off this and making the environment cleaner, I do plan to help with the idea of going to Mars. Now, this one would take a lot longer to do, but I think it's totally possible to use our hydrogen to make rocket fuel instead of burn unconventional fuels like methane, or I'm forgetting the other one. It would take a lot more weight to make those rockets because you also have to have a separate oxygen can and tubes and compression, because hydrogen itself can't burn without oxygen. That's why it, mixes back and burns clean, unlike a fuel like methane, which self-oxidizes. Now, with a hydrogen and water tank, yes, you could run it, and it would take a very specific mixture to get the proper amount of thrust and, efficient burns. But it's not impossible. It'll take years, possibly decades, maybe centuries. But I'm hoping to be the first person to take a step into changing our world. Thank you.